Yellowstone supervolcano and how its gases from deep underground reveal Earth's primordial chemistry. The supervolcano revealed new clues about Earth's chemistry, and it sheds light on how life came to exist on our planet. I have been wanting to do this for the longest time. I just now remembered the Yellowstone diatoms, and I have to make a video on that because diatoms give us our oxygen as well. Now, volcanic gases at Yellowstone have helped scientists better understand when elements like carbon, oxygen, and nitrogen arrived on our planet. Up to now, scientists believed large amounts of these volatile elements were wiped out about 4.5 billion years ago when a Mars-sized object struck the planet to form the moon, as the theory goes, but were later resupplied through asteroid and comet impacts. But new research led by geologists from France challenges that theory by analyzing the chemical composition of gases trapped thousands of miles under Yellowstone National Park. The research was carried out by scientists from Centre de Recherche Petrographique et Géochimique in France, that is the Center for Petrographic and Geochemical Research, Oxford University as well of the UK, and Institut National di Geofisica in Italy. Dr. Peter Barry of the Woods Hole Oceanographic Institute of Oxford says Yellowstone is the ideal location to study Earth's primordial chemistry, as the volcanic gases released there have a source deep within the planet, provided a view of the most pristine parts of Earth's interior. By analyzing small amounts of the gases krypton and xenon, the scientists were able to determine the origins of volatile elements such as water deep underground. Krypton and xenon are classified as noble gases, which mean they are not affected by chemical and geological processes. As a result, the gases act as a fingerprint of sorts. They keep track of where volatiles came from even after 4.5 billion years of Earth's history. The researchers found these fingerprints matched signatures obtained from meteorites, but the study also found many of the noble gases trapped in Yellowstone's mantle have been trapped for most of Earth's history. The key gas used in the study was an isotope of xenon known as xenon-129, and according to Professor Bernard Marty from the University of Lorraine, there are 9 isotopes of the noble gas. There are variants in the number of neutrons within the element. He said xenon-129 is unique because it forms from the radioactive decay of iodine-129. Iodine-129 has a very short half-life, and it has all decayed into xenon-129 after the first 100 million years of Earth's history. The noble gas was then trapped in place, giving scientists a chance to study it. The researchers found that xenon gas at Yellowstone is different from the gases found at other volcanoes where the samples are much closer to the surface. And the result is that the gas most likely mixed between the deep mantle and the amount of material arrived late on Earth's surface would have been limited. The findings suggest Earth kept onto its volatile materials despite violent formation. And the findings also suggest that late delivery of volatiles through comets and asteroids may not be necessary to explain the origins of life on Earth. The study was supported by European Research Council, the Deep Carbon Observatory, and Sloan Foundation. It was published in the Proceedings of the National Academy of Sciences of the United States of America. And the study says volatile elements play a critical role in the evolution of Earth. Nevertheless, the mechanics by which Earth acquired and was able to preserve its volatile budget throughout its violent accretionary history remains uncertain. In this study, we analyzed noble gas isotopes in volcanic gases from the Yellowstone mantle plume, though thought to sample the deep primordial mantle to determine the origins of volatiles on Earth. We find that krypton and xenon isotopes with a deep mantle have a similar chondritic origin to those found previously in the upper mantle. This suggests that the Earth has retained chondritic volatiles throughout the accretion, and therefore terrestrial volatiles cannot solely be the result of late additions following the moon forming impact. That sounds a little bit scientific, but what they're trying to say is that these elements are not the results of asteroids and comets striking the Earth, but they were there from the beginning. This is on Express UK by Sebastian Ketley. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.